here you all probably already know what a smart contract is, but I just kind of want to go over that just because it's something just to be really aware of so we're all on the same page, right? So basically, the thing I want to remind everyone, if you've gone through any of my courses, that we really do consider Ethereum a global computing platform. It's a lot like cloud computing, it's just in a different configuration, a different shape, with a different database backend. And smart contracts basically ride on that global computing platform. You pay for your services, the computing power that you use, by spending gas to complete a program, to do a thing with it. Now, smart contract programming, again, it's just a language, high level language. There's a couple of them. There's Rust, there's Solidity, then there's a bunch of other programming languages you can use, like Python and Java and others. Now, Solidity was and is a programming language developed specifically for Ethereum. So it's really tied to the EVM, the Ethereum Virtual Machine. It is the most commonly used smart contract programming language right now. But again, there are others. Now, the techniques you're going to learn here in this class are going to apply to just about everything else that we've got out there. So if you're working with Vyper, Bamboo, LLL, Rust, or anything else, and just kind of take a step back and go, okay, what techniques work here in Ethereum and Solidity that may work in Vyper, Bamboo, and something else, right? And again, if we're all programmers and we're all IT people, and we're always going to try to go to the latest and greatest because I want to keep on building my skill set because that's what makes it fun. Now, as a code set, right, smart contract is a self-executing piece of code that is deployed to Ethereum, and basically it supports ingrained into the Ethereum virtual machine. You can enable some really cool custom data types. You have access to and the ability to modify contract storage, which is super important, especially if you want to keep some things private, like the DAO wallet or DAO contracting and everything else. So all of this stuff is specific to the Ethereum platform. So that's the one thing you really kind of want to pull with this. Solidity is really tied to the EVM and was built for Ethereum. So what compromises the language? Basically, variables, functions. It's a statically typed language. Data types cannot be changed at runtime. And it's pretty handy. By doing this, type errors and other runtime exceptions can be prevented. Again, it's easier to understand, it's easier to maintain, it's easier to QA. So when you're part of that Ethereum ecosystem and smart contract programming language, you really do get the features and tools you need to develop and just deploy smart contracts. That's its whole sole function in this world, is to develop and deploy smart contracts. You're not going to get a whole bunch of groovy UI things in there. It's really more of just, hey, if X happens, do Y, and you just program what X and Y are, and there's your smart contract. Now, there are some really good, and you should be really familiar with, ready-made library of functions, especially systems like OpenZeppelin. There's a lot of other really cool stuff that's going out on GitHub with this, and this will ease the speed of code development and smart contract through code reuse, which there are problems with. But if you're using a really trusted system like OpenZeppelin and others, you really do get a best of breed, most secure, blah, blah, blah kind of code that you can reuse and you can call, right? You will call these things because it really makes your life a lot easier. Now, really cool DeFi hacks analysis. If you haven't gone in there, you really should go take a look at this site because they really cover the root cause of some of the biggest hacks in the DeFi space, the distributed finance space. And it's amazing because most of it's coding errors, right? The insufficient data validation, access control, price calculations, reward calculations, a lot of other issues that are just built based in the code, probably because they didn't have access to a course like this, because they're the most common reason why smart contracts are hacked. The more you understand why code is hacked, the better you can just arm yourself, right? And again, this is not just for programmers. This is for your QA people, and this is for your security engineers. If you know where the most common issues are, you can go through and look for those most common issues and then go fix them. It's really simple, right? Now, there are some rules and conditions to smart contracts and how they work, especially how it behaves and interacts with other contracts and external actors, whether that's a person or another contract or something else. A contract's code encapsulates those rules and conditions that the EVM will enforce. Now, if you're working on a decentralized application and they're often, using your smart contracts, you're doing your peer-to-peer transactions, complex processes, all this stuff needs to be really well thought out, really well planned so you can manage your digital assets appropriately. Now, there's some real transparency, immutability, and security of smart contracts that make them pretty good for a wide range of applications. Because they're executed on the blockchain, your contract's stored on the blockchain, you can actually go back through and check all this stuff and see how it works. Now, if you can do that, so can the hackers. So you really want to make sure that you're doing all the right things, at least to minimize that threat surface, that attack surface. You really want to make sure, because even if you think your code is proprietary, if it's out in the blockchain, it's transparent. It's just going to be part of the process. Now, there are some rules and conditions to this. Again, when you first write your smart contract, you're doing it in a high-level language, right? Then you're going to compile it into bytecode. It allows it to be deployed to the Ethereum blockchain, and then the EVM can execute it. So just like any other thing, right? You write your code, you dump it into your operating system, and the operating system runs it. It's what we do everywhere, right? No big deal. Now, what's always interesting is you want to make sure, based on a set of inputs, a smart contract will always produce the same output given a specific set of inputs. And if anything is outside the bounds of those specific set of inputs, you say, no, I'm not going to work. I'm going to error out. This is not what I wanted. This is not what I expected. Teach your contract about good touch, bad touch, however you want to do it. But you really want to make sure that in your smart contract that you're automating those complex processes to facilitate reliable and predictable interaction between multiple parties. And again, one of the most common examples I use is I'm growing coffee in Peru and shipping it to Seattle. And all those steps are going to be pretty transparent, right? I'm going to have a certain amount of coffee that I'm paying per pound or per ton or per kilo. And then all that's going to get shipped and it's going to get offloaded. These are all reliable and predictable interactions. The only thing that's really going to differ is how much coffee is grown in a season, how much my shipping costs are going to be, right? And those are all things that I can negotiate and store actually off-chain and then call those. And it's because of that transparent nature of the contract that I can go ahead and audit and verify it. Now, if I'm storing all that data off-chain, right, the cost of coffee, how many tons are being shipped, cost of this, cost of that, I've opened myself up to a third external call, a third-party external call, or my own external call, maybe something I negotiated, but I'm storing that off-chain. It doesn't mean that someone can't come along and say, oh, wait, Dan's got this really super lower price for coffee, so I'm going to use his price per coffee. So someone's going to make a call to that portion of my smart contract on the coffee price. So you do want to be really aware that people are probably going to use chunks of your code as you kind of go through this, right? Now, there's some real benefits to this, especially savings and autonomy, right? If you can just set out a contract, here's where everything happens, you're eliminating your brokers, your intermediary, you're basically eliminating the risk of third parties manipulating the agreement because now you've got some off-chain data stored, right? And that lack of intermediaries means the costs are overall supposed to be reduced, right? The other thing that's interesting too is that you can actually kind of keep a backup that's kind of immutable, right? Blockchain documents are duplicated, right? So everyone's got a copy of the documents and they may actually have a copy of your pricing, right? Depending on how you store it on-chain or off-chain. And again, when we get into storage, there's some real interesting things to consider there, right? Smart contracts are encrypted. Cryptography protects them from unauthorized access. Now, public means public, private means private. So just remember what you're doing when you're programming this, right? Effort, smart contracts automates business processes, especially if it's a repeatable one. If I'm always going to buy coffee from my farmer in Peru, man, we just set it up so it just runs every year whenever the coffee crop comes in. I save a lot of time. I may just have to pick up the phone, check out what the price per coffee is on the exchange, negotiate that price and call it good, right? So we can eliminate some errors caused by manual filling out of multiple forms because people hate filling in data on forms. We make errors all the time. So there's some really good reliability benefits to having that smart contract. And of course, there's limitations. The ability to change is difficult, right? Remember, the blockchain is immutable. Once your contract's on there, it's on there. So every time you make a change to that contract, you're actually having to issue a new issue of the contract and then make sure everybody knows the new issue of the contract. So once you have an error in there, once you have a problem, that code can be time consuming and expensive. Because remember, it costs money to put stuff on the blockchain, right? It costs money to put your smart contract out there. It can cost like $5,000 depending on how expensive or how difficult your contract is, how big it is, right? There's some loopholes, right? We can't program everything. You're going to do some good faith, right? But it's difficult to ensure that smart contracts are executed exactly according to the terms because we can fake Oracle data. So you can do this as a check 3 different versions. There's different ways of handling Oracle data and bringing in third-party data into your contract. But we do want to do good faith, but it's always going to be trust but verify. Always, 100% of the time, trust but verify. Third parties, we do want to involve third-party involvement, but if something happens like the ship sinks when it's on its way to Seattle with my coffee, I'm going to have to deal with a third party because hopefully I insured that coffee shipment, right? So in case of smart contracts, you may not need a lawyer to prepare the individual contracts, but you're going to have to work with your developers so they understand the terms and can help create the codes for whatever third party issues like insurance, lost at sea, damage, and what happens if the coffee is not up to standard. Coffee got burned somehow or it got destroyed somehow or some bug got put in with the coffee, and even though it arrived here in Seattle, the container was filled with bugs, right? That's all going to involve third party. There's a lot, again, when you think of your smart contract, you think of all the things that can go right and go wrong. Now, terms sometimes are going to be vague. So if you have a vague term and condition, then it's not going to be well understood and it's going to be hard to execute or hard to put in your contract language. So again, make sure everything is really crystal clear and you've tried to do your best to think everything through about what can go right and what can go wrong. So there's some real limitations in there, right? Code will execute exactly as you told it to execute. If you made a mistake in the instructions, that's kind of it. So smart contracts, brilliant idea. They make a lot of use. They're in use now. They transfer billions of dollars every year now, right? So when they do good, they do great, right? But they're also kind of super hackable, right? There's been billions of dollars in losses because of faulty coding practices, right? Those fault coding practices are going to be on the developer or trying to get to market too fast, not really paying attention to what you wanted to do. You saw the end goal, but you thought anyway it was going to go, and you made a mistake in the code. Contracts based on code, whether it's Solidity, Rust, Viper, whatever, you're going to use you're going to use good code libraries. Make sure you're always using good code libraries like OpenZeppelin. Again, I'm not making an endorsement here. They just happen to be the ones that are in the forefront of this right now and have a really good process for making sure of how this all works and how code is checked, including a bug bounty, right? Now, smart contracts have also led to a plethora, and I love that word because it is many poor code and bad examples, bad code reuse. You'll see some of those examples as we kind of go through this class on what is good code and what is bad code. And someone's going to come along 5 years from now, 2 years from now and go, oh, boy, damn, that was a bad code, because this industry changes, right? Because we're changing all the time. You do have major updates, and sometimes those major updates are breaking updates. So pay attention to this class as we kind of move along with all the updates that are happening with this language. And then really understand the rules, the benefits, and the libraries. Make sure that you're working with some kind of DevOps, QA, CI/CD, SecDevOps process, right? You can't get away from the process. You really want to have that multiple set of eyes. Make sure that people understand their roles and what to look for. And again, classes like this will just make it a little bit easier if you're doing a safety stand down or something else, or even just curious about how this would work. Make sure you're tying things like Truffle or Foundry or other systems into your DevOps QA process, so that as you're checking in code, you're automatically looking for the top 100 top errors or top 10 errors, and then not allowing that code to be checked in until those errors are fixed. And again, that will just bring you right into lines of Google or Amazon or Microsoft or any other development group that actually knows what they're doing in terms of how process should work to make sure the code is as clean and as safe as possible. So that's kind of it for an overview of smart contracts and where we're going to kind of go with this class. I know you've probably seen smart contracts all over the place. You know what they're all about. But again, just we're taking a different tack here. We're looking at the secure programming viewpoint, and that's going to include a lot of issues, a lot of things to look for, where your DevOps and your SecDevOps and QA and everybody else are going to fit into this process. so we understand the roles and what to look for as we go through our day. All right, that's it for this lecture. I will see you in the next one.